Okay, basic trig graphs are y equals 1 sine of 1x. But we just write that as sine x. We put all those ones there. I put those ones there so you can like abundantly make abundantly clear. An absolute value of 1, the absolute value of the amplitude equals 1. And then 2 pi over 1, the period, equals 2 pi. And then these values are going to appear all over the unit circle. So my amplitude is 1, I go up 1, down 1. I go right 1, 2, 3, 4, and I put 2 pi there. Some people put the 2 pi down here so it doesn't interfere with their graph. Half of 2 pi is pi. Half of pi is pi over 2. You multiply pi over 2 by 3, and that gives you 3 pi over 2. And these items are right off the unit circle. If you look at the unit circle, it'll say sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is negative 1. Sine of 2 pi, it repeats itself, it goes back to 0. So you start to get that repeating fashion, and you get those spots of y equals 1 sine 1x right off the unit circle. The unit circle is sometimes used to graph the trig functions. The same thing is said for cosine. So if I were to graph y equals 1 cosine of 1x, I can get the amplitude. And the amplitude, the absolute value of the amplitude would be 1. The period would be 2 pi over 1, or just 2 pi. So this amplitude, I go up 1, I go down 1. I go right 1, 2, 3, 4, everybody get on the dance floor, and I put 2 pi there. Again, I'm putting it underneath so it doesn't interfere with my curve. Half of 2 pi, halfway is just pi. Half of pi is pi over 2. Multiply that by 3, or count. 1 pi over 2, 2 pi over 2, 3 pi over 2. Cosine of 0 on the unit circle is 1. Cosine of pi over 2 is 0. Cosine of pi is negative 1. Cosine of 3 pi over 2 is 0. Cosine of 2 pi is 1. And then that graph is going to oscillate.
Okay, so now again? Yeah. So by the time of that, the protein values, they give us some of the values pretty quickly. So
The 0 is undefined, so if I draw my x-axis and cotangent of 0 is undefined, that means I have a vertical asymptote there at 0. I'm going to go right 1, 2, 3, 4, 1, 2, 3, 4, and find out where the next vertical asymptote is. So I go over and I notice the next vertical asymptote is at pi. So this spot here is going to be pi. That's going to be my next vertical asymptote. Then I'm going to figure out what half of pi is. Half of pi is pi over 2. Half of pi over 2 is pi over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4. Then I'll figure out what cotangent of pi over 4 is. Notice, according to this student, cotangent of pi over 4 is 1. So I go up to 0, or I'm sorry, pi over 4, 1, and pop a dot. Pi over 2, cotangent of pi over 2 is 0. So I pop the dot on 0. So pi over 2, 0, pi over 4, 1. 3 pi over 4, 3 pi over 4 is negative 1. So you can get the trend of this curve. Creeps down along that vertical asymptote, goes through that knee, goes through the turning point, goes through that knee, and then goes down south.